Part two coming at you. So we are still talking about areas of circles and areas inside circles, as well as the arc lengths. However, we are kind of transitioning to the second part of the notes here. So first part was talking about the formulas, the formula for the arc length and the formula for the area of the sector. For the second part, we're mostly going to be focusing on this formula, the formula for the area of a sector. So for the second part, they're asking us to find the area of each shaded region. So in order to do these problems, in order to find like each of these individual parts, we got to get a little bit creative with how we find the area. Now, if I were to, let's say, ask you to so in each of these, they ask you to find the area of these little extra parts right there. Those are called segments of a circle. But I don't really like that term because we already used segments before with like line segments and stuff like that. So what I like to call these is a sliver of the circle, because it's kind of just like a little extra bit shaved off there, right? So if you're trying to find that sliver of the circle, the big idea to take away from it is that if you want to get this like sliver piece, so if I have this little bit right here, in order to find this sliver piece, what I need to do is I need to take the area of the whole sector, so take this whole sector area, and what I'm going to do is I'm going to subtract out the area of that triangle inside there. So I'm just going to subtract out this triangle area. And I'm going to do that for both example 3 and example 4 here. So so we'll give that a shot. All right, so for example 3, the first thing we need to do is, if we're trying to find the area of the sliver, so the sliver here, what we need to do is find the area of the sector, then find the area of the triangle. All right, so I'm going to clear up some space here. So keep this in mind. Area of sliver is equal to the area of sector minus, to take away the area of the triangle. So we're going to do that right now. So I need to erase this because I need some room. Okay. So now what that is in mathematical or in algebraic terms is the area of the sliver, or the area of the shaded region, is equal to the area of the sector minus the area of the triangle. And now we got to figure this out. So let's do that. So the area of the sector is going to be equal to, or area of the sliver, sorry, is equal to the area of the sector, which, to find the area of this whole sector, what we need to do is we need to use this formula right here, area of a sector, right? X over 360 times pi r squared. So in this case, my angle measure here is 90, so 90 over 360. Pi r, which is 24 squared. And then we are going to subtract out the area of this little triangle. So the area of the triangle is just 1/2 base times height. My base is 24, my height is 24. The reason these are equal is because both of these are the radius of the circle. So 1/2 24 times 24. So now that we have all this written out, now we just start plugging it into the calculator. So this is going to be 1/4 pi times 24 squared. I need to use my calculator for this one. 24 times 24 is 576 minus 1/2 576. All right, now this is going to get a little ugly, but I think we'll be okay. So I'm going to take 576, multiply it by a fourth. That's going to give me 144 pi. And then here, I'm going to do 1/2 times 576. 576. And that's going to give me 288. So I think your teachers are going to have you leave it in terms of pi. So you can just leave it as like this. If you wanted to find the exact, an estimated area of this sliver, you would just plug this in your calculator and get your answer. 3.14 minus 288, and I get 164.16. And that's the area of that sliver right there. Okay, let's try it again. So again, it's just to review, area of the sliver is equal to the area of the sector, which is this whole area, minus the area of this triangle. So we're going to do it again with this example right here. Same process, but now we have a little bit messier numbers. So area of the sector, the area of the sliver, is equal to the area of the sector, which in this case is 120 over 360 pi r, which is 18 squared, minus the area of this triangle. Okay, this is where it gets interesting. We don't really know the area of this triangle yet, do we? No. So what we need to do, we know the area of a triangle is 1/2 base times height. We don't have a base and we don't have a height. We know this side is 18, so that's kind of nice. But what we need to do here is we need to construct an altitude. So now we have two triangles that both have a hypotenuse of 18, and they're both right triangles. That's cool. However, something we kind of note here, this whole angle here is 120 degrees. So if I were to draw this altitude of this isosceles triangle, what's it going to do to this angle? It's going to split it in half. So this angle is going to be 60, which makes this two 30, 60, 90 triangles. So I can figure out the length of this base. So this is the hypotenuse of my right triangle, which means that this side here is my small side. So that's going to be equal to 9, which means that this side is equal to 9√3. Same thing over here, 9√3. So draw an arrow. That medium side we said is equal to 9. Or small side is equal to 9. So then we just take, now we have a height of our triangle and we have this base, which is 18√3. So we plug that into our formula. 1/2 9 times, I'm running out of space, 18√3. Oh gosh, running out of space a lot. So let's simplify this. So this is going to be 1/3 pi. 18 squared is 324. Minus 18√3 multiplied by 2, so 9. So this is going to be 81√3. Let's do 324 times 1/3, and the area of that sliver is going to be equal to 108 pi minus 81√3. So this one was a little bit difficult because we had to use 30, 60, 90 triangles. But the process is still the same. To find the area of the sliver, you take the area of the sector and you subtract out the area of the triangle. And you guys will be asked to do this on your homework and maybe a skill check in the future. So give this a shot. It's just this same conceptual idea every time. All right, now let's take a look here. So 5 and 6 are a little bit different now, right? So here we have a shape inscribed in a circle, and we're asked to find the area of these shaded regions right here. So there's a couple of ways you can do this. Yeah, there's a couple of ways you can do this. Really, what I need you to think about is like, what shapes could I like subtract out here? What could I do to kind of manipulate the area and try to figure out these different shaded areas? So here, when you immediately look at this, it's like, hey, it's a circle, and inside that circle is a square. So I know I can figure out, if I wanted to, I could figure out just if all these were shaded, I could figure out all these areas here by just taking the area of the circle and taking away this area of the square. I'd be left with 4 equal slivers here. And then from there, if I only wanted 2 of those slivers, since I know they're all equal, I could just divide the answer by 2, and I would just get these 2 slivers. So let's give that a shot. So we are going to say the area of the shaded region. So the area of the shaded region is going to be equal to the area of the circle minus the area of the square, and all of this being divided by 2. Because we only want half of these. We only want half of these slivers. All right, so let's do the area of the circle. The area of the whole circle, well, it's kind of unknown to us right now. What we need to do is we need to find a radius. So what I'm going to do is I'm going to draw a pair of radii right here. Boom, boom. All right, so we know this is a square. So if this is a square, what type of triangle did I just make here? That's right, we made a 45, 45, 90 triangle. So 45, 45, 90. And in a 45, 45, 90 triangle, the hypotenuse is equal to x root 2. So then to figure out what x is, divide both sides by root 2. Multiply by a fancy 1, multiply by root 2 over root 2, just to get the thing on the bottom here to cancel out. So I'll have 4 root 2 over 2, which is just equal to 2 root 2. So that means that both of these sides here are equal to 2 root 2, which means my radius is 2 root 2. So let's plug that into our formula. So area of circle is just pi r, which is 2 root 2, squared, minus the area of the square, which is just 4 times 4, which is 16. Let's figure this out. So this is going to be 8 pi minus 16 over 2, which is equal to 4 pi minus 8. And that is your area of the shaded region. Okay. Now, my question to you guys is, for example, what's the difference between example 5 and example 6? Well, in example 5, the square is taken out, whereas example 6, the square is left in. Right? That's like the big difference here. So what we need to do, there's like two different ways to really kind of like think about this. But what I would do here is I would find, so the area of this, to find the area of the shaded region, We know that, so there's two ways to look at it. We can use the last problem to help us out with example 6. Since they're both squares, we found that these two shaded areas is equal to this, 4 pi minus 8. So if we know that these two shaded areas, are equal to this 4 pi minus 8, then the area of the shaded region in this case is equal to this stuff we had before plus this square, which is a 4 by 4 square, which is going to be 16. Which means that in the second problem, the area of the shaded region is just 4 pi plus 8. Now that's one way to do it. Can you guys, my task that I'm going to give you guys is there another way to do example 6 that maybe uses no prior knowledge from the example before? So I want you guys to try to figure that out. Your homework's down below, number 16, an angle described in semicircle is right. So this is a right angle, just know that. And that's all I have for you guys. Thank you guys for listening, and I'll see you all in class.